Hello friends, let us begin the topic of eigenvalues and eigenvectors, which will be very useful in as far as even examination is also concerned. So let us begin the topic of eigenvalues and eigenvectors. Okay, let us first define the concept here. So any non-zero vector x is said to be an eigenvector of a matrix A. It's a square matrix we are given. If there exists a number lambda such that Ax equal to lambda x, where A is a square matrix, say Aij, and X is a column matrix like this, x1, x2 and so on, xn. This is a non-zero. This is a non-zero vector. Okay. Now this lambda is called eigenvalue. Lambda is called eigenvalue of a matrix A. This is also called characteristic root. So next, see, we are having Ax equal to lambda x. We can write this as lambda I x. Okay, and so here Ax equal to lambda x, lambda I x. So this we can write A minus lambda I x, and this is a zero vector, zero matrix. Now this matrix A minus lambda I. So the matrix A minus lambda I, this is called the characteristic matrix. Is called the characteristic matrix of A. So here determinant. Now next is the determinant of A minus lambda I. So how it looks like? It looks like this: A11 minus lambda, A12 and so on, A1n. then A21, A22 minus lambda, and a to n. This is a1n, and so on. an1, an2, and so on, ann minus lambda. So this is nothing but a polynomial in lambda of degree n. So this is called a characteristic polynomial. That is called a characteristic polynomial of A. And the equation determinant of A minus lambda I equal to 0. This is called characteristic equation. This is called a characteristic equation. And if we solve this equation, so the roots of this characteristic equation is called, the roots of characteristic equation are called eigenvalues of matrix A. So our aim is now to find out how to find out the eigenvalues. So if you are having a, suppose say 2 by 2 matrix, so suppose A 2 by 2 matrix. So first we need to find out the characteristic polynomial. So in 2 by 2 matrix, characteristic polynomial is like this. It is lambda square minus s1 lambda plus s2 equal to 0, where s1 equal to sum of main diagonal elements. It is also called trace of A, and S2 is determinant of A. Similarly, if we have a 3 by 3 matrix, say suppose A is a 3 by 3 matrix, then how to find out the characteristic polynomial? So it is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0, where s1 equal to sum of main diagonal elements. So that is also called the trace of A. Then S2 is sum of minors. We know how to find out the minors of main diagonal elements. And S3 is determinant A. And there are some properties that we shall discuss later on, but at least one or two property we can mention here, that the sum of eigenvalues, so that at least you can check whether your eigenvalues are correct or not, is nothing but the sum of the principal diagonal element, that means trace of A, and the product of eigenvalues. product of eigenvalues, and that is nothing but determinant of it, so that you can check whether your answer is correct or not. Okay, let us solve examples. So let us solve some examples. Question is, find the eigenvalues and eigenvectors of the matrix 5, 4, 1, 2. So let us first take 2 by 2. So let us see. So let A equal to 5, 4, 1, 2. Now first we find characteristic equation. And characteristic equation is determinant A minus lambda I equal to 0, and another way is also this one, lambda square minus s1 lambda plus s2 equal to 0. So that is lambda square minus s1 lambda plus s2 equal to 0, where s1 is the trace of A, that means the sum of the diagonal element, that is 5 plus 2. So that is 5 plus 2, and so that is a 7. S2 is determinant A, and so that is a determinant 5, 4, 1, 2. So that is, now that we know how to find, 5 2s are 10, then minus 1 into 4, 4, and so that is 6. So therefore characteristic equation is lambda square minus s1 lambda, so minus 7 lambda, and plus s2, so 6 equal to 0. Now we need to solve this equation, so that is not difficult. 6 1s are 6, minus 6 minus 1, so that is lambda minus 1, lambda minus 6 equal to 0, and therefore lambda equal to 1 comma 6. So therefore eigenvalues are 1, 6. Now we find eigenvectors corresponding to each eigenvalue. So eigenvector for say lambda equal to 1. Now so eigenvector for lambda equal to 1. So we need to write the equation A minus lambda I x equal to 0. So A minus lambda is 1, so A minus I x equal to 0. Now here we are having A here and A minus lambda, so A minus lambda looks like this. A minus lambda I is 5 minus lambda, 4, 1, and 2 minus lambda. So from that A minus I, lambda is 1, so 5 minus 1, then 4, then 1, 2 minus 1, okay, and x. So x we can write say xy, and 0 matrix is 0 matrix. So this is nothing but 4, 4 1 1 xy equal to 0 0. So basically we are having only one equation, that is x plus y equal to 0. If I write 4x plus 4y, that is also x plus y. Okay, so only one equation, x plus y equal to 0. So if we can take, say, y equal to t, then x is minus t, and therefore x is equal to eigenvector xy, and so x is minus t, y is t, and so we can write t minus 1 1. Okay, so therefore eigenvector for lambda equal to 1 is a vector minus 1 1. Now we can find eigenvector for lambda equal to 6. So eigenvector for lambda equal to 6, and so again we are having like a minus lambda I x is, so this is a minus 6I x, and so this is equal to 5 minus 6 4 1 2 minus 6, and this is xy and equal to 0 0. So that is minus 1 4 1 minus 4 xy equal to 0 0, and here also we can see that minus x plus 4y, x minus 4y, so both are the same equation. So we have basically only one equation, minus x plus 4y equal to 0, and here also if we can take y equal to, say, t, then x is equal to 4t. Okay, so therefore x is equal to xy, and so this is 4t t, and so this is t 4 1, and therefore eigenvector for lambda equal to 6 is a vector 4 1. Okay, let us solve one more example. Find the eigenvalues and eigenvectors of the matrix 4 6 6 1 3 2 minus 1 minus 4 minus 3. So let us solve. So let a equal to 4 6 6 1 3 2 minus 1 minus 4 minus 3. Now we know what is the characteristic equation. So characteristic equation, we know this is a minus lambda I and its determinant is equal to 0. Okay, and we also have the characteristic equation as lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. Now s1, so that is nothing but the trace of a, and trace of a, that means sum of the principal diagonal elements, and so that is 4 plus 3 plus minus 3 and that is 4. S2 is nothing but the sum of minors of principal diagonal elements of A. And so now let us find the principal diagonal element for say 4. So for 4, the principal diagonal element, you have to just hide the first column, first row. These are the 4 elements we are having, and these 4 elements we need to find its determinant. So that is the minor of 4. So that is 3, 2, minus 4, minus 3. Then plus. Now the minor of this 3. So we need to hide this second column, second row. So these are the 4 elements: 4, 6, minus 1, minus 3. So 4, 6, minus 1, minus 3. Then the minor of this minus 3. So we have to hide the third column, third row. So these 4 elements are there: 4, 6, 1, 3. So the next is 4, 6, 1, 3. And it is easy to find the determinant. This is minus 9 plus 8. The next, minus 12 plus 6. Next, 12 minus 6. And then we can easily find this is minus 1, minus 6, plus 6. And so that is minus 1. What is S3? S3 is determinant of A. So determinant of A, so 4, 6, 6, then 1, 3, 2, then minus 1, minus 4, minus 3. Okay, so let us find the determinant. So that is 4. We know how to find out the 4. Then we need to consider these 4 elements. And so that is minus 9 plus 8. Then minus sign, and this 6. So 6. What are the 4 elements? You have to hide second row, first column. So this 1, minus 3, minus 1, 2. So minus 3 plus 2. Then plus 6. So you need to take these 4 elements. So minus 4 plus 3. And so this is equal to minus 4, then plus 6, and then minus 6. So that is nothing but minus 4. So therefore, characteristic equation is lambda cube minus s1 lambda square, and s1 is 4. So minus 4 lambda square, then plus s2 lambda. Now s2 is minus 1. So this is a minus lambda, and plus minus s3, and s3 is minus 4. So minus s3, that means it is minus minus plus 4, and that is equal to 0. Now we need to find the values of lambda. That means we need to solve this equation. So first let us solve by trial and error. So if I take say lambda equal to 1, does this equation satisfied? Left side you put the value of lambda to be 1 here. So this is 1, then minus 4, minus 1, plus 4, and so equal to 0. That means lambda equal to 1 is a root. Now once lambda equal to 1 is a root, you can easily find the other. So this is the method. You put 1 here, that is the root. Put the coefficient of this polynomial, that is 1, minus 4, minus 1 and 4. Okay. Then begin by writing 0 here. Then you add these two, and so this is 1. Then multiply these two, so this is 1. Again add these two, so this is minus 3. Then multiply these two, so minus 3. Again add these two, so this is minus 4. Then multiply these two, so this is minus 4, and here it is 0. So now we are having in one bracket, you are having lambda minus 1 because 1 is a root, so lambda minus 1 is a factor, and from these are the coefficient of the remaining. So that means now lambda cube is there, so it will be now from lambda square minus 3 lambda minus 4 equal to 0. So this will become from here now. Now this is minus 4. So you have 3 ones are 3, minus 3. You need to find out the roots. So this is 4 ones are 4, minus 4 plus 1. So this is lambda minus 1, lambda minus 4, lambda plus 1 equal to 0, and therefore lambda equal to 1, 4 minus 1, and therefore the eigenvalues are 1, 4 minus 1. Here you can verify your eigenvalues. Like the product here is what? Product is minus 4, and product is same as determinant. So what is the determinant? Minus 4. Then sum is the trace. Sum is 4. Sum is 4 here. Sum of the eigenvalue is 4. And S1, what is trace? Trace is also 4. So that means our eigenvalues are correct. Now find eigenvectors for each eigenvalues. So what is A minus lambda I? So that let us write here. So that is 4 minus lambda, 6, 6, 1, 3 minus lambda, 2, minus 1, minus 4, minus 3 minus lambda. Now let us find the eigenvector for lambda equal to 1. Eigenvector for lambda equal to 1, and that is nothing but A minus lambda I x equal to 0. So A minus I x equal to 0, and so this is equal to 4, lambda is 1, so 4 minus 1. So this is 3, 6, 6, 1. This is 3 minus 1. So this is 2, 2, minus 1, minus 4. And this is minus 3, minus 1. So that is minus 4. And x, y, z equal to 0, 0, 0. So now we take the equations. See here we observe that 3, 6, 6. So 3x, 6y, 6z. If I divide by 3, it will be x, 2y, 2z. So these two equations are same. So only we take these two equations, consider second and third. Okay, we would like to use the Cramer's rule. Let us see how. So this is x plus 2y plus 2z equal to 0. That is from second, because first and second same. And third, minus x minus 4y minus 4z equal to 0. And now by Cramer's rule, now this is easy, x over then equal to minus y over and equal to z over. Now x over, you just hide the x, so consider the coefficient of y, z here and here. So these 4 elements write down in the determinant, that is 2, 2, minus 4, minus 4. Similarly for y, you need to write the coefficient of this x and the coefficient of z. So that is 1, 2, minus 1, minus 4. And for z, you write the coefficient of x and y. So that is 1, 2, minus 1, minus 4. And so this is now x over, it is easy to find the determinant, minus 8 plus 8. So that determinant is 0. Minus y over, this is not divisible, divide by 0, okay, do take care, it's a ratio. Minus 4 plus 2, minus 4 plus 2, okay, so that is minus 2, equal to z over, this is minus 4 plus 2, and so that is minus 2. And so this is x over 0, y by 2, z by minus 2. And so we can also write this is x, y over even 1, because you can take this and z over minus 1, because it's a ratio. And therefore x is equal to x, y, z, and so this is equal to 0, t, minus t, or you can say t, 0, 1, minus 1. And therefore eigenvector for lambda equal to 1 is 0, 1, minus 1. Now we can find eigenvector for lambda equal to 4. So that is a minus lambda I x, and therefore a minus 4 I x, and therefore now a minus 4, so we need to take minus 4 here, minus 4 minus 4, and so that is nothing but 0. Then 6, 6. Then this is 1, 2, and 3 minus 4, so minus 1. So 1 minus 1, 2. Then minus 1, minus 4, minus 3, minus 4, so minus 7. So minus 1, minus 4, minus 7. Then this is x, y, z, and that is equal to 0, 0, 0. So we are having 0 into x plus 6 into y plus 6 into z equal to 0, or you can say 0 into x plus 1 into y plus 1 into z equal to 0 from first. And from second we have x minus y plus 2z equal to 0. And by Cramer's rule, you can take second and third, you can take first and third, you will get the same answer. X over, now we can easily find the value here, 1 1 minus 1 2, 1 1 minus 1 2 equal to minus y over, so you don't write to this, you have to write this one, this one, this one and this one, that is 0 1 1 2, and z over, so this 4, that is 0 1 1 minus 1, and so this is now determinant x over, this is a 2 plus 1, so that is 3. This determinant 0 minus 1, so that is minus 1. This determinant 0 minus 1, so that is minus 1. So we are having like this, therefore x by 3 y 1 z minus 1 equal to t, and so eigenvector, this x is equal to x y z, so this is now 3t t minus t, and so this is 3 1 minus 1, and therefore eigenvector for lambda equal to 4 is 3 1 minus 1. Next we can find the eigenvector for lambda equal to minus 1. Eigenvector for lambda equal to minus 1, and so here we need to take a minus lambda I x equal to O, therefore a plus I x is equal to O, and so we are having now okay, so therefore a plus I, okay, so now here 4 plus 1, okay, so that will be nothing but 5, lambda is minus 1, so this is 5, and remaining two elements same 6 6. Next is 1, now lambda is minus 1, so minus 1 here is 3 minus minus 1, so that is nothing but 4, and other element same. Next is minus 1 minus 4, and the minus 3 plus 1, so that is minus 2. Then x y z n is equal to 0 0 0. So now this is nothing but 5x plus 6y plus 6z equal to 0, x plus 4y plus 2z equal to 0. Now we can apply Cramer's rule, that is not difficult now. So x over coefficient of yz, that is 6 6 4 2 equal to minus y over coefficient of x and z 5 6 1 2 equal to z upon coefficient of x and y 5 6 1 4, and so we can have x, this is 6 2s are 12 minus 24, so that is minus 12. Then minus y, this is 5 to the 10 minus 6, so that is 4. And here 20 minus 6, so that is 14, and that is equal to t. And therefore we can have x over, we can have the 2 divided by 2, so that is minus 2, no sorry, minus 6, then y over divided by 2, so minus 2, and z over 7. So the eigenvector x, x, y, z, and that is minus 6t, minus 2t, 7t. You can take even minus t also outside, no problem, or t also, so both are the same. 6 to minus 7. And so therefore eigenvector for lambda equal to minus 1 is 6 to minus 7. So this is the way you can able to solve the example. Thank you.